Okay, I see quite a number of participants. They have joined. There are 17 attendees, and yeah, I just confirm that uh, I'm audible. It's visible. There are no issues on that particular front. Okay, many other people they have also joined. Wonderful, right? So, friends, I'm assuming that everything is fine on the connectivity front, audible and visible both. Thank you so much, Ravi and Ankit. So, let's get started. So, good morning, all learners. Right. So, welcome to the MBX program, and I think this is the fourth term in this particular program. Right. So, I congratulate you that you have made it up to this particular point. And the course that we are going to deal with is the machine learning one. Right? And this is probably, if I'm not wrong, the first formal introduction to machine learning. I'm pretty sure that you had courses in the area of statistics and then probably Excel modeling, Python. You already had those courses, but this particular course is the first formal introduction to machine learning. So what we'll do is we will start a little slow in the sense that I'm sure that many of you are from a diverse background. So I have seen the profile of the people who are attending this, right? Yeah, I mean, the range is pretty wide, and it's so nice to have a vibrant set of group of people attending the session. So what we'll try to do is we'll try to keep it in a level, at least for the first one class, one or 1.5 class, so that it's understandable to everyone. In the meantime, my request to all of you would be if you would like to make the most of these sessions, the live sessions, please just go through the recorded content points, right? That will help you build enough knowledge and idea about this particular part. And then once you are in the live session, we can actually discuss more things, discuss real life case studies, examples. And if you have some doubts, you can very well clarify that, right? So that's the format which we will do. And we'll try to have the class interactive in the sense you'll find that in the Zoom, you have this option to raise your hand, right? I'll just show you. So there's this option called raise hand, right? So in case if there is an issue, right, just raise the hand, and I'll probably pause and try to address whatever issues that you're having. From time to time, you can also use the Q&A. So in the Q&A, whatever are the open questions, right, we try to address that without disrupting the class. We try to do that, right? Okay. So if you have some questions, let me repeat, please put it in the Q&A. If there's something which requires my urgent attention, please raise the hand and I'll come to you. At the end of the session, what I'll do is I'll make the session open, and there probably we will have a interaction whereby whatever points which you're having, whatever queries that you're having, I'll be happy to take all of it, right? So with this, let me get started with this course mapping. So this will be the agenda for this session, right? That what exactly is machine learning, the day-to-day usages, the kind of workflow which comes in the process of machine learning, right? Some kind of overview of the course, some of the terminologies people are being using, right? And this summary and discussion. So that is what will be the agenda for this particular session, right? And before I proceed, here are some of the disclaimer and the acknowledgement, right? So all the content which probably I am going to use in this particular session. So I acknowledge this creators, this wonderful books which are out there, right? For example, the first one, this one, Data Mining Concepts and Technology, right? Wonderful book, have been in the market for quite some time. Still, it's one of the most sought after books. If you would like to get some more details on this particular field, some advanced concepts, definitely go through this. Then there's other one, which unfortunately is not available in India anymore, is Laros and Laros, is a father-daughter pair, who had this books called Data Mining and Predictive Analytics. That's also a wonderful piece, right? If you get a second-hand copy of this book, yeah, Just try to pick it up. And then finally, one of my favorite professors, Dinesh Kumar, right? Business analytics, the science of data-driven decision. This is also a pretty wonderful book, right? Many examples are there in the Indian context. It's one of the fastest selling books in the analytics part, right? Dinesh Kumar, I know him personally, great person, great mentor. Just probably, if you get a chance, pick up that. Otherwise, here are some online resources coming from medium.com, Analytics Vidya, and YouTube. This particular guy, Joe Strummer, I've seen his contents to be pretty useful. So these are probably some of the things that you can refer to. Okay. So here is probably what we will be doing in this machine learning one. Right? An overview of this entire machine learning. What exactly is this machine learning? When do you need to use machine learning? The workflow. What do you mean by data pre-processing? How do you select models, train and evaluate them? Right? So these are some of the things probably will take care of it. Right? Also, along with that, you'll get to know that what are the different broad kinds of machine learning models. So I'm saying broad kinds, right? So the broad kind, there you have this supervised learning, unsupervised learning. These days, a new branch that has also got added to this, which is called the reinforcement learning. So these are some of the things which comes out there. In the case of supervised learning, you have regression models and you have classification models, right? So in this first machine learning one, we are going to restrict ourselves to mainly the supervised learning part. Even in the machine learning 2 also, we still continue with the supervised learning, while in the machine learning 3 that you are having, right, that is when some bits of this unsupervised learning also comes into the picture. Right? That is what we will cover in the term 1, right? So before I proceed, I would like to hear from your side. Do you have any kind of a specific request or any kind of thing that you would like to let me know, right? Your expectation from the course, right? What exactly do you plan to get from this course? How do you would like to use this course in your job, in your work, in your career progression? If I can get some ideas of that, right? You can just write the responses in the chat box. If I get some responses, it will be easier for me also to probably touch upon or address some of those parts, right? So from your side, probably I'll expect some messages on the chat whereby your part as to what you get out of this particular course, what is the expectation from this particular course, what do you intend to learn from this particular course. So those are probably some of the things which I would like to hear from your side, and then we'll try to see that how much of it we can address. Right? If someone has already given something in the Q&A, okay. Okay, so there's someone from an anonymous attendee who's saying that, do we expect to learn NLP along with machine learning? Is it the part of the same domain? Yes. So yes and no, both this thing. So NLP or natural language processing, it's indeed a part of machine learning. Yeah, it falls in the same domain. But again, in terms of our coverage, I don't think we covered NLP, at least in term 1 or term 2. Term 3, we just briefly touch upon natural language processing or NLP. We briefly touch upon it, but yeah, that is it, right? We probably will give you some idea, but in terms of creating NLP models, in terms of working with life problems in NLP, no, I don't think that's in the scope of this particular program, right? This is a MBA program, right? So we keep it at a level where you can appreciate the whole part, right? I hope I have answered the question for you. Okay, there's some more questions. So Vinay is saying that not exposed to machine learning other than knowing a few applications, looking forward how it can be used by individual without much of coding knowledge or software development. Okay. Creating basic models using Python. Okay. Ravi is saying he's from a non-IT background, so would like to know how you can apply this to sourcing and procurement domain. Okay, wonderful. Sourcing and procurement domain. So Ravi, please make sure that not in this particular class, but the next three classes that we'll be having, right? Pick up this particular theme from time to time, sourcing and procurement, right? In fact, in some of the examples which I'll give you, maybe some part of it will cover, but yeah, if you can come with some more examples from this particular part, right? We can actually discuss in more details, right? Okay. Yeah. Anyone else? Anyone else? Satish is saying, is ML relevant to marketing and sales? For marketing, very much relevant. Very much relevant. For the sales part, yeah, it is relevant if you have the right kind of a data. If you get the right kind of a data, it is relevant for the sales also. For example, I'll tell you, right? Right now, globally, Salesforce is one of the most popular CRM platforms in the world. Salesforce, right? And Salesforce, it actually intended to make the whole process of getting leads, right, converting that to opportunities, deal closure, all that particular part was its forte. Right? So this is also what it is doing. It has actually created a platform called Einstein on top of Salesforce, the CRM platform, which what it is doing is it's actually getting more predictability and more efficiency in the process in this whole thing. Right? It's actually trying to predict that given the inputs that you have given, right, what can be probably the size of the deal, what are the things which are really important in that particular deal, right? So those are some of the things which people are already working on, right? So yes, Satish, machine learning is very much relevant to marketing. In the sales part also, in bits and pieces, it's being used. Right? Okay. Coming to the expectation, which Vinay had said that not exposed to machine learning other than knowing a few applications. See, coding knowledge is required, right? In the sense, if you like to create these models, some bit of getting your hands dirty should come in the process. Right? Without getting your hands dirty, you'll probably be able to appreciate what the things are doing, but not fully able to realize the potential which it is having, right? So that will be required, right? To some bit, it will be required. And Shashi is saying creating basic models using Python. Yes, Shashi, we are definitely going to do that. But again, one thing which I see batch after batch. So here are probably some group of people who doesn't have too much of a technical knowledge, and they would like to know machine learning, right? There's some people who comes purely from the business side, and they would probably like to know more about the use cases. And there's some people who are probably actually working in the development phase, and they actually would try to create these models using Python. So these are the three generally kind of cohorts which are there in all the batches. So what, see, we can't like address any particular individual or any particular kind of fate completely. But what we'll try to do is in the process, we'll try to touch upon each and everything which you have said, right? Even if it's not in very details, but yeah, we'll probably do it in a level whereby you will get comfortable with the concepts and some bit with the applications. Right? That's what we are going to do. So we have only 4 sessions and we'll spend roughly about 10 hours time together. Right? So whatever is possible in those 10 hours, definitely I'm going to do that for you. Make sense? Okay. Let's move ahead then. So to know a particular field, right? I firmly believe that to know the future, you need to know the past also. So quickly, I'll just take you through some of this, right? These are just for your knowledge purpose. Obviously, I'm not going to ask any questions from this, but this is how you can get to know more about this particular field, right? Even for people who are from a non-technical background. So before 1600, what happened was this empirical science was there, right? So things like, how this force of gravitation, those things came into the part, right? This planetary motions by Galileo, all that was empirical science, right? People observed something and empirically they would have tried to do that. So that happened before the 1600 empirical science. 1600 to 1950. This is the time when the theoretical science came into, right? This is the part when the theoretical science came into the process. So each and every discipline, what they were supposed to do is they were supposed to build the background theory. So even when I'm saying theory, that can also mean in mathematics. So all that part has to be built, and then it has to be applied on the empirical front, right? So the whole notion changed. So earlier it was empirical science, which you saw something, and then you were trying to figure out the theory behind it. And 1600 to 1950 is the other way down, right? Theoretical science, where you are actually trying to develop some kind of a theory which explains many of the phenomenon which we see all around, right? In fact, the education that we had, a large part of it is attributed to or borrowed from the theoretical science. And then come to 1950s to 1990s. That is basically the era of the computational science, right? So this is the time when computers, they became popular slowly from the domain of military. In fact, you might not know that in some form or the other, computation was being used in the military domain. It was used, right? So this computational science, right, first started with military, and then slowly it came into the purview of this academics, then to the industry, and you saw some of the larger companies like your Hewlett Packard, HP, right, and then your companies like Intel, then companies like let's say this IBM, right, they flourished big time during that particular era, right, and in the computational science, what happened was we were actually trying to put a situation, and the computer can probably try to find some kind of a solution to it. That was what we were trying to do with computational science. And then 1990s onward, which is going on till now, it is the era of this data science. What happened in the 1990s? One significant advancement was this start of this internet, right? So internet also, it started off as a DARPA project, right, by the defense. Sorry, it started off as a project in the defense, and then slowly it came into the domain of academia for transfer of academic researches, notes, and then all of a sudden it found mainstream, where people like you, me, all of us, we were using. And in the process, what happened was that data became democratized. This particular era gave rise to some of the prominent companies in the world which are still ruling. To name some of them is Amazon, right? Amazon started in 1995. Google started around late 1998. Yahoo, which is no longer out there, right? It also started in the mid 1990s. So all these are some of the very prominent companies, and all that they were doing was basically managing data. Right? And once this data became democratized, so many different kind of new business models started getting developed in and around it. Right? Okay. So this, whatever I've said, this comes from this wonderful paper, The Worldwide Telescope, Archetype for Online Sciences. Just go through it, a wonderful read. Okay. So landmarks in the modern day machine learning, right? So in 1763, Thomas Bayes, he actually laid the foundation of the probability, the probabilistic theory, right? And you'll be surprised to know that most of the models that we work in the area of data science, statistics also, and in machine learning, a large part of it, is probabilistic, right? More than 70% of the model that we build has some bit of probability lying within it. Now, Pierre Simon Laplace, famous French mathematician. He devised the method of least squares, which led to a popular technique called regression, which even after more than 200 years still stands strong. Right? A model, if you can turn it around with some kind of a regression example, regression probably theory behind it, that is still one of the robust models that you can create. And then 1913, Andrei Markov, he came up with the concept of a Markov chain, which once again deals with a higher level of probability, in the sense when there are multiple objects, multiple entities, right? Even entities means beings like us. See, all of us, we behave in some kind of a probabilistic manner. In the next 1 hour, I can exactly tell you with some bit of probability that what are the possible actions that you are going to have, right? All the possible actions that you're going to do. I can't say for sure that, okay, all the people for the next 1 hour, they'll be right standing in front of the screen and probably listening to what the faculty at the other end is saying, right? Can I guarantee that? No, I can't guarantee that, right? Even if you're doing that, how your mind is working, right? That's also something on which I don't have any control. So all these are probabilistic in nature. Whatever is happening in that particular front is pure probability, right? And what we'll try to do is we'll try to make some kind of a understanding of this whole part as to how from probabilistic part we can probably give some kind of a deterministic duty. I'm sure people here are have joined this particular session from all around the country. Anyone who's there from North India, Kashmir, or maybe from the mountains, high altitudes of Sikkim, Manali, anyone like that in the class? No. So let me ask you, right? Again, you can just put some random thoughts onto the chat box. Okay, so Sunny Kumar is there. He is from Katra, Jammu. Welcome, Sunny. So if I ask you that what's the chance that it is going to snow today? What is the chance that it is going to snow today? So I think except for Sunny, right? Maybe most of the other people, they will say it is 0%, right? See, it's not actually 0. It will be a very, very, very small number, right? Which would probably be close to 0. But again, let's say you're in some place like Michigan or Detroit today. If I would have asked you this question, you might have come up with some answer like 15%, 18%. Vis-a-vis, if I ask you this question, that what is the probability or chance that the temperature is going to be more than 35 degrees today? More than 35 degrees. Right? Yeah, some numbers, if I can see on the screen, temperature is going to be more than 35 degrees today. Some numbers, again, it can be random number, right? But again, some kind of a thoughts I'd like to see from your side. What's the probability that it is going to be more than 35 degree in temperature today? Shashi is saying 90%. Okay. Some other people might say 40%, 50%, whatsoever. See, all of you are in some way, some kind of an agent in the system, right? And if I take your collective intelligence, right? If I take your collective intelligence, then from this collective intelligence, right, you are assigning some kind of a thought process to some particular events, right? Some kind of a number out of 100 you have given. If I take the average of all that number, it's precisely going to give me the chance that a particular event is going to happen today. So be it raining, be it snowing, be it having a high temperature, all that are nothing but some form of probability. Can I say with 100% surety that it's not going to rain today? I guess not. Right? With this high temperature, high heat, it might so happen that in some parts it starts raining. It might so happen, right? So there's always some kind of a probability. And Andrei Markov, what he came up was with the concept of this Markov chain, which deals with all these entities, probability entities like this, and the interaction which they're having before they can come to a steady state. Okay. And then in 1950, something remarkable happened. Alan Turing, he came up with this famous seminal paper and posed the questions that can machines think? And that actually started this whole revolution in this computing first. And then as you're seeing that you have things like ChatGPT, which can almost converse with you like that of a real human being. Right? This is where we have headed in the last 70 years. Right? Okay. So this is the evolution of the modern machine learning. As I said, 1950, Alan Turing proposes the machine learning part. 1952, Arthur Samuel developed the first machine learning program to play checkers. Right? And then 57, neural network program to simulate the brain happened. 67, nearest neighbor. This is, by the way, the first model that we are going to learn. Right? Let's jump a little bit from 67. Right? All these are also important landmarks. But let me come to 97. So this is the time when I was in colleges, and it was a big news that the world champion Gary Kasparov. So he gave all the grandmasters during that time a tough time. So he was the reigning world champion. Right? He played with Vishwanathan Anand also. Right? And he was a master in this particular game. Right? And Gary Kasparov was beaten by IBM's Deep Blue machine. That really brought back the focus of machine learning, computing, and everyone took a look. And then come to 2006, Netflix, your favorite Netflix, they launched a machine learning competition. And their postulate was very simple, that whoever can better our machine learning algorithms by at least 10%, we will give them $1 million. Right? So $1 million in 2006, it was a lot of money that day. Today also, it's a considerable amount of money which is out there. But yeah, that was what was said. And then deep learning was conceptualized. Now, why I mark this is deep learning in some way or the other. It is linked to this neural network program, right? So it took almost 50 years for the deep learning to be conceptualized from neural network. Why? Because again, the computing power, the data till this time was not sufficient. So this was the first time when formally deep learning started becoming mainstream. Then in 2016, AlphaGo program beats the professional human player. And in 2022, I have not added that particular part, this ChatGPT, it actually passed the Turing test. So these are some of the important landmarks in the evolution of the modern machine learning, right? Since we're talking about so much about machine learning, let's first focus on this particular part of learning. So what exactly is this learning part? So Herbert Simon, right, a famous Nobel laureate, right, a behavioral scientist, he said, learning is any process by which a system improves performance and experience. Mind it, he doesn't say a human, he says a system improves performance from experience. Now, what's a system? A system can be people like you and me. A system can be even animals. A system can also be machines, which human beings they have only developed. So it's a process by which a system improves performance from experience. That particular part is very important. Performance from experience. The other way looking at it is that process of gaining information through observation, right? We gain some kind of information and then we create knowledge from it. That's also learning, right? So then the next question is that why humans learn, right? We all are in this quest for continuous learning, but why is that we learn, right? If I can get some responses on the chat, why is that we learn? Why is that we learn? All of the people, right? I see some 30 odd participants who are there. They have joined this particular session to learn something. Why? Why are you learning? Why is it required? So Kern is saying continuous development. Manish is saying to improve. Very good. Yeah. Anyone else? Shashi is saying to discover what we don't know. Fair enough. Anything else? Anything else? Nazanin is saying to get a live load. Fair enough. For growth, sure. I think most of you are correct. See, why we basically need to learn is at the end of the day to progress in some way or the other. Back in our ancestral days, right, when humans were nothing but a cave animal, in those days also they were continuously trying to learn. They found that the stones which are out there, they are very hard. So rather than probably tackling an animal with their bare hands, if they can use the stone, maybe they will get an advantage, right? Then they figured out if the stones they can be sharpened, that will probably help them make a bigger impact, right? So in this particular way, continuously humans are learning. So some of the things what we do in the process of learning, one is basically to carry out some particular tasks, right? So you day to day you are carrying out some particular task, and you'd like to improve on that particular task, right? So to carry out certain tasks, we learn to make the improvements and this continuous improvement. I think most of you have already said this, and these are probably some of the reasons why we learn. At the end of the day, we learn because we would like to progress, right? We learn because we would like to make better of whatever we are doing daily. So those are some of the reasons for what humans learn. And then how do we learn? One is you learn from experts, learning under expert guidance. So think of your old school days, right? When you have just entered the school, you didn't have any idea about alphabets, right? You have been taught all those A, B's, C's, and then from that, slowly you started creating some word. From the word, you derived their meaning. You arranged a few words to create sentences, right? And then from the sentences to paragraphs, and then all the way to blogs, books, and whatsoever. But every time what you're doing was, in the beginning, you were learning under some expert guidance. So today also, many people said at the very beginning that you would like to know this field of machine learning, right? You don't have much idea. So here probably you are trying to learn from some kind of expert. That's what you are trying to do. The second one, create newer learning from whatever experts taught. See, after you have probably graduated, if you have to pick up some new topic, some new learning, I think from that, you pick up some books and whatever the existing knowledge that you have, you start learning under the guidance of the existing knowledge. So new knowledge you create under the guidance of whatever existing knowledge that you have. So creating new learning from whatever experts taught you. And then the third one is learning through a repeated process of failure, right? So you see, our sports people, like a batsman like that of Virat Kohli, you remember, right? He had a very bad time in between, right? Not getting runs. It was a process of failure, but again, through the failure also, he was continuously learning till the time he became perfect. If you remember, for people who knows how to cycle, if you remember your cycling days, what happened was initially it was difficult for you to make the balance. You are falling, right? But again, after a certain point in time, you actually learned that how to do that, and that probably will remain with you throughout your lifetime. Self-learning, right? Okay. So that brings us to what exactly is this machine learning, right? So maybe it helps if I can get some input from your side. What do you think is machine learning? What do you think is machine learning? Now that I have said enough about learning, so what do you think is machine learning? Yeah, anyone? Feel free to share your perspective, right? We'll discuss. What exactly is this machine learning? What is machine learning? Okay, some answers are coming. So, Pritpal is saying converting information to knowledge. Okay. Jyotishman is saying ability of the machine to learn from its activities. Okay. Machine learning by itself acting on its own. Machine update data for desired output. Okay. Okay. Anyone else? Anyone else? You are probably talking about some of the points, but not exactly out there. Mimicking human actions without human interventions, ability to think, converse like human. Okay, very good. That was Madhuri. Madhuri, I think, wonderful response. Machine learns from previous input by users. That is what Ravi is saying. Fair enough. Fair enough. So again, if you go to the books, right, there will be so many definitions of these books, right, coming from the books, right? Automatically learning to model relationships between set of descriptive features, targets, right? They are very complicated. But again, in a nutshell, machine learning is nothing but the ability of us to probably make the machine use the same kind of a logic that we use for our own learning. Right? I've already shown you that how we learn, how humans learn. So our ability to basically teach the machine that how to learn, and in the process actually ensuring that the machine learns some particular tasks, right? So through machine learning, what we are trying to do is we are actually trying to push the machine to mimic the way in which we humans we learn, right? Okay. So here is a formal definition of machine learning by Thomas Mitchell. It says a computer program is said to learn from experience E with respect to some particular class of task T and performance measure P if its performance at task T as per measurement through P improves with experience E. What does it mean? Complete Greek, right? Okay. So let me make it easier for you. Anyone who probably cooks well in the class is a decent cook, maybe from the boys, he's a decent cook. So when I'm saying decent cook, I'm excluding things like Maggie, right? So I'm excluding things like Maggie, but anyone else who's a decent cook, can please raise your hand. I'll probably put you Shreya. So Shreya, fine Shreya. If I don't get anyone else, I'll probably come to you. Anyone else? Anyone else? So Nilesh is saying only dal, rice, and paneer tikka. I think Nilesh, that will work for me. So let me just put Nilesh on the mic. So yeah, Nilesh, I've given you the listing too. So Nilesh, you cook basic thing, right? Dal and all those things. That's what you're saying. Yeah, Nilesh, if you can come onto the mic, it will be easier. Is it possible? Is it possible to use your mic? Unmute. I think I've already unmuted you. Let me just check. Let me just check. Yes. Yeah, Nilesh, I've unmuted you. Yeah, Nilesh. I think there's some kind of a problem at Nilesh's end. So maybe Shreya, I'll come to you. Let me just. So Shreya, I have given you the permission, the mic permission. Yeah, Shreya. I'm not able to hear. So Shreya, you can just unmute. Cannot unmute. So I think I have given you the permission to unmute. Just try it out once again. Try it out once again. I saw Nilesh unmuting himself. So I'm sure, Shreya, you also will probably be able to unmute. Just check. Anyone else? Anyone else? I would really like to hear this from someone else. Yeah, anyone else who probably can volunteer in the cooking part? Yeah, anyone else who can volunteer? Nikhil, just try out once again, Nikhil. I am just try out once again, Nikhil. Because I saw that you were unmuted. Nikhil? I think probably it's not working out. Anyway, then let me probably take this up for you. Okay. So let's probably take the example of the first day. Maybe you had started cooking. Let's say you started cooking dal, right? And you can probably write in the chat, Nikhil or Shreya. So what was the first experience, the first day when you cooked? How was the quality of the final outcome, the dal which you had created? Was it mind-blowing, extraordinary, just average, or probably not very well? So Nilesh is saying that not up to the mark. So when Nilesh, you are saying that it is not up to the mark, so which means that you have already started comparing, right? So maybe you are comparing this dal to probably something which probably your mom made, or maybe someone who cooks in the home, he or she makes, right? That's what probably you have been comparing. And the comparison, what happened was your dal was not up to the mark. Maybe you had put too much water in it. Maybe you had put too much salt in it, or probably cumin, whatsoever, right? So that was the first dish experience, right? So here, the task that you are having, you're trying to solve, is the act of making dal which tastes well. And the performance measure is probably the performance measure which has been set by your mother. And the first experience, not very well. But then what happened is that with time, you gain more experience. So the next time when you cook dal, maybe it was not that bad like the last time. Maybe this time only the salt was not proper. Third time you do, the salt was probably fine, the haldi was not proper, right? And then like this, you actually, what you're doing in this particular task of cooking the dal, you're getting more and more experience. And how you're measuring that experience? You are measuring the experience through the taste, and you probably would like to have the taste almost similar to the one which probably your mom had cooked. And once you see that, okay, you have probably reached a state where your performance, maybe it's not like your mom's, but at least it is closer to your mom's performance, then you say that, yeah, I probably have learned how to cook dal. And that exactly happens for the machine as well. So what you give a machine is some particular task to perform, right? That particular task can be, let's say, as trivial as doing some kind of a prediction, right? Even making some calculations, everything, that's a task. And with this task, what you provide it is enough experiences. This experience comes to the machine in the form of data, right? So in fact, I mean, I took up this example of dal, right? You may not have noted it, but again, if you have noted it, you probably had created some kind of a model saying that, okay, this is the amount of heat which I'll give to the dal, right? Then probably I'll apply the water. I'll let the water boil up to a certain temperature, keep it like that. Then I'll add the other masalas, ingredients, right? I'll let it soak for some more time. and after this particular time, I'll probably stop the cooking part. All these are nothing but data points. And what you have done is you have fine-tuned these data points to the experience part. That's what helped you in the learning part. And that's what exactly we try the machines to learn, so that they learn from this experience which comes from the data. They're able to continuously measure themselves against the performance till the time that they have aced the whole process of learning. That's what we try to do, right? Everyone clear? Everyone clear? I hope so. You got the idea? Okay. Now coming to the experience part, what exactly is experience? Exposure to large volume of past example or data points. That's the experience part, right? And this is the data which you are going to use to learn, right? So for the case of Nilesh, he continuously learned from his past experiences, past failures, right? Till the point his dal test was comparable to that of his mother's, right? So what you did in the process, right? This experience, it actually helped you create some kind of a rules. So all those things which I said now, those are nothing but some rules. That heat the water up to this particular level, right? Make sure it is boiling, right? See the color. These are nothing but some kind of a rules. So this experience will help you create the optimal rules. This experience will help you create the optimal rules, right? And this learning will happen from the data, and this data only will guide you to those optimal rules. That's the explanation part, right? So famous quote from Einstein: information is not knowledge, only source of knowledge is experience. More experience you become, right? More knowledge you get. Okay, so coming to the types of machine learning which are out there. Now that we basically know what is this learning, how does this machine learn, right? So here in this machine learning, we have in these days 3 kinds of learning. I told you at the very beginning. One is supervised learning, other is unsupervised learning, and the third is this reinforcement learning. Supervised learning, what exactly is that? There is some kind of a supervision in this whole learning process, right? So let's say that you are doing this cooking and your mother is beside you, and your mother is constantly guiding the beta or beti, do it in this way, otherwise it will get wrong. So if you are getting that supervision continuously, then that is the supervised learning part. Most of the models that we will learn in machine learning 1 as well as in machine learning 2 is the supervised learning part. So what are the characteristics of supervised learning? One is the data is labeled. So a particular process is given, and against the process it is written failure. Some more data points are given: processes, failure, processes, failure, processes, failure, process, success, process, success, process, failure. So like from this whole combination of success and failure, you are able to figure out. So this is a bad feedback which has been given to you. That okay, what makes a process successful? Vis-a-vis, what are the things which will make the process failure? And what you will try to do is that you would try to create successful processes and reduce the failures in the processes to the maximum possible extent. That is the supervised learning part. So the data will be given to you along with the result. Data will be given to you along with the result, right? So you see that this particular thing that these famous players, what they will do is that they will rewind their own performance in the match. He will see that, okay, in this particular moment, this particular ball, I probably should have played it like this, but I played it the other way around. That's why it led me to losing my wicket. So they are also continuously trying to learn from that. Some kind of a supervision is there. Then come to the next one, which is the unsupervised learning. What happens in the unsupervised learning is that there is no supervision like we had in the supervised learning. The data is given there, and what we try to do is we try to find out some kind of a traits or hidden patterns in the data. Right? That's what we try to do. Some kind of a traits or the hidden patterns in the data we try to find out for the case of this unsupervised learning. Right? The third one, which is making a lot of waves these days, the reinforcement learning. Right? This is basically learning from the process of examples and making mistakes. You reinforce the learning when it is good. You probably make some penalty when the learning is poor or bad. That's the reinforcement learning piece. Right? So let's come to the supervised learning, the first one. So in the case of supervised learning, what happens is that you have a well-defined output. We have a well-defined detailed output, and the objective is to learn the relationship between the set of inputs. The example of making the dal, what you tried to do over the period of time was try to find out the relationship between these inputs, that okay, how can I optimally make this dal? And the defined output was that whether the taste will be good or the taste will be bad. Right? And you are seeing all these examples, and from that you are trying to figure out that what makes the best dal. Right? So these are some of the things which are being given there. One is from your past record, the label data is provided. Past input and output pairs, right? The label data is given. So if you had recorded all the instances of the cases where you failed, right? Failed. On some particular day you did well, right? Failed. Some particular day you did well. And then if you're sitting with the data, I'm sure you'll be able to make out that what creates this particular process, right? So the model tries to learn or derive the output based on the inputs which are given. And then the model will figure out that what best combination of input will give me the desired or the right kind of output which is out there. Right? Fair enough? Okay. So what kind of an output level can be there? So output level can be categorical. The output level also can be continuous. So examples of categorical level, yes, no, true, false, right? Say for example, you are at the road, right? Examples like red, green, yellow, these are categorical output. You go into the stock market, buy a stock, hold a stock, sell a stock. All those are examples of categorical output, right? And the other case is the output may be continuous. Predicted amount of rainfall, number of customers, price of stocks. These are nothing but continuous output levels. Fair enough? Okay. Machine learning in our day-to-day life. Spam filtering. I'm sure that most of you use some kind of a mail services like that of Gmail or maybe Outlook, right? And very distinctively, they have created one particular section which is saying this spam filtering, right? In fact, when Google came out in the market with their mail services, the Gmail, I think Gmail started somewhere in 2003. People actually asked this question to them, that there are so many mail services out there, right? At that point in time, you had this Hotmail from Microsoft, right? And you also had this Yahoo Mail. So all those things were there. So what's the need of another mail services? Is what people had asked, right? And what they did was they actually created their USP was that our mails, one is that it can be very well searched. So they brought in their search technologies even in the mail, right? Which is, by the way, a very wonderful feature. And the other one which they did was they actually created some kind of a model through which these spam can be filtered. In the process, I'll tell you a very interesting story how they did the spam filtering. They actually put in a bunch of engineers, PhD peoples, and made them read through a lot of mails and told them that, okay, can you figure out which is a spam, which is a not, right? So day in and day out, these people, what they had to do was they had to just read these mails and find out that which one is a spam and which one is a not, right? Day in and day out, they were doing. To the point, they almost started questioning themselves that, is it that something which I'm going to do for the rest of my life? Reading emails and saying, is this spam or not, right? So at that particular part, uh, then Google came back to them, took a test that how much proficient they have been in terms of determining the spam versus the non-spam mails. All of them, they came up with flying colors in that particular test. And then they were being asked that whatever logic you had applied to figure out the spam versus not spam, please apply the same logic in a machine and create a system for that. And that's how billions of emails a day, which probably would have wasted our time a lot, ends up in our spam boxes. Most of the time, we even just don't bother to look into them. We just go ahead and delete those mails. Spam filtering, right? Web search. The web search, which was made popular by the likes of Yahoo, Google, Microsoft, that also uses a lot of machine learning. Postal mail routing, that how the mails will be routed, right? All the parts, that's also where a lot of machine learning happens. And along with that, things like fraud detection, movie recommendation, right? Advertisements, social network, speech recognition, right? Speech recognition, which happens in your Alexa device, or maybe your Siri, Google Assistant, all are examples of machine learning in our day-to-day lives, right? Recommending movie based on your past data, based on what you have liked, right? What kind of shows you have given a thumbs up, right? What kind of shows you have watched. All those things are taken into account for giving the movie recommendations. These are practical examples of machine learning in our day-to-day lives, right? So I'll probably pause a little bit, and maybe what I'll ask is, Ravi. So Ravi, you are working in the sourcing and the procurement domain, right? Do you have any instances where you think that machine learning could have been used to make the work much more simpler, easier? Yeah, Ravi, you can probably put your note on the chat box, right? But again, for the things like procurement also, right, they actually uses a lot of predictive model space. Right? It will be very unfair if just when you don't have anything in your warehouses, that's only when you trigger the procurement part. That's bad, right? Rather, I think it would be a much logical approach whereby you could exactly predict that when your supplies are going to be over. You also know from the past data that how much time it takes for you to get the new supplies. And you use all of this and probably order the supplies much well in advance before it probably requires replenishment. Nothing but example of machine learning. I hope, Ravi, the example was relevant. Right? Okay, let's move ahead. So typically, machine learning will help us tackle two things. One is the computational part. The other is the inferential part. Let me first come to the computational part. So here I'll give you an example of the Google ophthalmologist. So Google, I think around 2017, it came up with this Google ophthalmologist, which it was found out that it is about 97.4% accurate in determining any problems that you have in your eyes. Whereas a typical human is around, I think, 93.2% or 93.4%. I'm sorry, this was 97.3%. This is 93.4%. a typical human doctor, right? So here, this is machine, this is human. That's the efficiency. So do you think that the machine fundamentally is better than the human? Is the machine fundamentally better than the human? What's your take on this? You can say yes or no. So my question is that, is the machine more intelligent than that of the human? The answer is yes or no. Nilesh is saying yes, very good. Vidpal is saying no. Usha is saying no. Jyotishman is saying yes. Nazneen is saying no. Nabarun is saying yes, no. Okay, so the class is divided. Right? I'll tell you my point of view. See, whatever we are today, right, whatever work you have today, is because of the kind of experiences that you have. This is the kind of learnings that you have. A typical human doctor, it has been seen that throughout his or her lifetime, is able to probably do justice, right, or see maybe between 6,000 to 8,000 cases, right? That is what a typical human doctor will do. For the Google machine, it was trained for 3 months. So 3 months, almost like 12 weeks. It was trained on 1 million patient records every week, 1 million patient records. So by the end of those 3 months, it had got trained with almost 12 million patient records. See, we also seek out doctors who are more experienced, isn't it? A doctor who's more experienced, have been in the trade for a long time, have diagnosed properly for a very long time. Those are the kind of doctors that we seek. And here you have a machine which probably has the experience of 12 million patient records. That's enormous, right? 6,000 versus 12 million, right? They don't even come in the comparison. So it is just in terms of the experience that the machine is probably beating the human. And the whole phenomenon is a computational phenomenon. Computational phenomenon. Why? Because machines are able to compute much faster compared to that of a human. Right? Nazdin has a question. I'll come to Nazdin. Yeah, Nazdin, I'll just unmute you. Yeah, Nazdin, you can probably talk now.
Well, so there could be a misunderstanding, but I don't have any questions.
Sorry?
I don't have any questions, sir.
Oh, Acha, I saw your hand was raised. I saw your hand was raised. Oh.
Apologies.
So one part is this computational part, large volume of data. And the other part is the inferential part. See, typically it has been seen that humans like us, we are good when we have to take decision based on one variable, two variable at max. The number of variable increases several fold. We actually find difficulty in taking some kind of judgment or some kind of inference. Human insights are inadequate. So those are the two things, computational and the inferential. Okay. So coming to scenarios where we can use machine learning. One is this human processing is slow or inefficient, right? You hear all these things now, that these machines, they will take your job, right? AI will take up all job and everything, right? I'm sure that most of us, we have been hearing this, right? So human processing slow or inefficient. So if you have those scenarios where you are not efficient enough, right? Make sure that someone will come up with something, right, through the help of machine, and that job will be at risk. Come to the second part, a task which is repetitive. A task which is repetitive. If there's some kind of a repetitive task, which means that the rules are pretty simple. You won't have to apply or go through too much of an ambiguity. So in scenarios like this, repetitive tasks best left to that of a machine. Best left to that of a machine. Right? And the third part is lots of data. Right? We see that if a lot of data comes in, we become inefficient. Right? If there was a human doctor who had to probably treat 1 million patients, so obviously for every patient, he hardly will be having a few seconds, right? And obviously few seconds spending time on patients, not really efficient. So that is when inefficiency will creep in. So these are the scenarios when you should be using machine learning, right? And then coming to the differences between this regular computing and machine learning, right? How many of you are programmers in this particular class? Programmers, right? You can just raise your hand. Programmers, right? Programmers, only one person. Madhuri, I'm sure there will be quite a few programmers, people who will do programming in their organization, working IT organization, doing programming. Okay, so coming to Madhuri, okay, two people are there, right? So coming to the two people who are there, when you do a traditional programming, what happens is that you have a fixed set of inputs, some test cases, against which a fixed set of outputs are required, right? That's how you test the model, right? So here, the rule is already known to you. You just implement that particular rule. The rule is already known to you, right? So that is typically a case of a regular computing, right? So here you have already defined the logic. You are just implementing that logic so that some form of machine can use that particular logic, right? So that's the regular computing part. Coming to the machine learning piece. So here, the machine itself has to figure out the logic on the basis of the past data. You are not giving the logic to the machine. Machine is figuring out the logic. The rule initially is not known. The rule is not known. The rule will become known in the passage of time, right? So that exactly is machine learning. With the passage of time, more and more data comes in, the machine becomes more and more efficient, right? Machine learning. So machine learning and data mining, in some way or the other, they are very closely related. And these are some of the fallacies, right? One is this data mining or machine learning can find answer to all business problem. But the reality is that no machine learning problem can find answer to all your business problems. It's you will have to probably pitch in, right? It's a automatic process, requires little oversight. But the thing is that even after you have created a very solid machine learning process, you still will have to monitor it, tune it, so that it doesn't make mistakes. The world is abound with this chat GPT, right? But again, I'm sure that you read that, I think a few weeks back, about 6 or 7 weeks back, I think Microsoft was using this chat GPT in the searches, and this chat GPT turned rogue, and it started threatening the user that I'll ruin your personal life, right? You don't know, right? I have all your information. I'll leak out the information to your prospective recruiters, right? I'm sure that you have read that particular instance, right? So it's not that it doesn't require oversight, it requires oversight. Third is it quickly pays off for itself. No, that's also wrong. It's paying it off for itself. It's a time-taking process, right? It depends on what kind of application is it, what kind of investment have you made for that application, right? And that it is easy to use, right? That also depends on the kind of knowledge, the kind of technical people which is there in your organization, right? Identifies causes of business problem. No, it is a fallacy, right? It will probably show you some particular indication, some particular traits, and you only have defined that based on this particular indication, particular traits, what does it mean for the business? So it doesn't identify the cause, it just identifies the traits, and you interpret that how this traits probably some back to my decision process. It automatically cleans the data in database. Once again, false. It doesn't automatically clean the data, right? The data cleaning part, you can prepare some kind of a rule, right? Generic rule, but even after that, a lot of cleaning you have to do manually. Then it always provides positive results. We don't know. It might provide a good result. It might provide a bad result, right? So there is no guarantee of a positive result. But again, it will give you some kind of insight, some kind of a learning you can always have from this data mining process, right? So this some earlier process defined it as an automatic, right? And that had actually misled people, right? So automation is there, right? Say for example, Madhuri only was talking about this RPA, or the robotic process automation. Here also, through a process of observation, analysis of a large amount of past records, past data, you are putting them to some automatic processes. But yet, this automatic processing that you are having, right? Is it that it is always 100% accurate? Is it that it's always 100% accurate? Madhuri, what do you have to say on this? Don't you find some cases which are probably aberrations, right? You find those cases, right? And then you have to refactor those cases into these processes, isn't it? Right? So it requires some kind of a human insight. What happens is that as the process becomes mature, the human intervention, it becomes lesser. But nevertheless, human intervention is very, very much required. Right? So humans need to be actively involved in this every phase, right? And the task of the data mining should be integrated in the human process of problem solving. And that's what we are trying to do these days, right? So people are blatantly using ChatGPT, but again, if you augment your learning, right, your task with that of things like this, you yourself become more and more efficient. So how should a process look like? A data mining or machine learning process look like? There's something called this CRISP-DM, or cross-industry standard process for data mining. Cross-industry standard process for data mining, CRISP-DM, right? And companies like IBM, so IBM, by the way, has purchased these pieces, right? So IBM, Daimler, Crossfly, NCR, they have actually contributed to this particular model, right? It started in 1996, still it is very much relevant today. And this is the CRISP-DM process. So what it says is that, right, you'll be learning this machine learning thing, you'll be learning so many techniques. And if someone asks you that, okay, here is a problem which I'm having, can you help me solve this problem? The first thing that comes to your mind is, okay, here are the 10 or 12 algorithms which Professor Saha has taught us. So let's try to find out that which algorithm will solve this problem. Completely wrong approach. It should first start with something called this business research or understanding phase. Right? First, find out more about this particular business, what this business is talking about. Right? Do a more research on that particular part. Right? So that's the business research understanding phase. Because if you don't understand the business, how will you solve the problem itself? And then from the business research phase, you go to something which is called the data understanding phase. Now that you have understood the business, then you probably know that the underlying data, what does it mean? When is that the business is doing well? When is the business is not doing well? What are the indicators for the business not doing very well? You all have seen this Hindenburg report, right? Which brought the Adani stock crashing. Right? What exactly had happened? What happened was that this particular group had a lot of understanding about the data and how it relates back to the business, right? So what it basically told in the report is in human readable language that how the data that they're getting from Adani's business, how it is actually probably affecting or mapping back to the business part, right? And to them, it seems that maybe the health of the business is not very good. That's what they came out, and rest, I think you know. The entire stock market, it took a bad hit because of this particular instance. Right? So once you have the business research, you have the data understanding, that's when probably you start doing the data preparation, start collecting the data, analyzing the data, clean the data if required, right? Remove the variables which are not that much in use. So all this you try to do in the data preparation phase. Post that, you have this modeling phase, where what you're trying to do is you're trying to use this data for the modeling purpose. After that, you do some kind of evaluation of your model. And once you're satisfied that the model is running fine, then you put that to the deployment piece. This is how you do. So in the first part, you see this business research with the data understanding. The process goes to and fro, right? You, as and when you get more understanding on the business, right? You get to understand the data even better. So business data, you reiterate to the part that you are completely confident about how the data indicators relates back to the businesses. Then from the data understanding phase, you have this data preparation phase where you prepare the data based on the data that you have collected. So from the data preparation, you do the modeling part, right? You do some prediction, evaluation using models, evaluation, and the final deployment piece. That's what you do in the first PM process. Very much relevant process, right? I think this is something that you should memorize and learn and use it for the lifetime. First DM process, right? So these are the different phases: business research understanding phase, data understanding phase, data preparation, right? Modeling, evaluation, and finally the deployment, right? Whatever we have discussed, it's all out there, right? See, people would try to make some distinctions between data mining and machine learning, right? This is coming from your slides only, async slides, right? Uh, I can tell you fundamentally one thing: the data mining and machine learning, they are siblings. They go hand in hand. They go hand in hand, right? So again, trying to distinguish them is probably not a very good idea. Many of the algorithms which we use in machine learning, they have their roots in data mining, right? They have their roots in data mining, right? It's only that machine learning right now can be used in a vast area because the business understanding and the data understanding, that has probably increased tremendously for us these days, right? But otherwise, again, if you give the data mining process the same kind of a business understanding and the data understanding, right, it will not get applied to limited area, but it will get applied to vast area. In fact, before people were talking of machine learning, they were actually talking of data mining, right? They were actually talking about data mining, right? So again, there is a probably some kind of initiative to distinguish between the two. I don't think there's too much of a distinction, right? It's almost the same, right? I'm just wondering, should we take a quick break and come back? It's 11:50 my clock, right? Should we restart the session at 12 o'clock once again? What do you say? Should we restart at 12 o'clock? Okay, so let me pause the sharing. Let me pause this sharing. So I'll pause the recording as well. So what we'll do is we will probably come back and continue at 12 o'clock with the rest of the class. Meantime, take a bio break, right? Have some water, do some stretching, and let's come back at 12. Okay, so I'm stopping my video and audio. We'll meet back again at 12 o'clock. Hello, welcome back to the session. I hope this break was good. So let me turn on my video again. Okay. So whatever we have covered till now, any question that you are having, whatever we have covered, I hope we are covering at a level which is understandable to everyone. I hope so. So Jyotisman is saying it's not understandable. Which particular part, Jyotisman? You can just specify which particular part you had some issues. I can probably reiterate those parts. Which particular part was not understandable? Okay, no questions. Okay, fair enough. Anyone else? Any particular part? Prithpal is asking, is data mining a subset of ML? See, these days, actually, data mining as a concept is not that much used. So here is a broad, which is AI. Under AI, you have data science. Under data science, you have machine learning. Under machine learning, you have DL. In fact, your data mining, I'll say, is basically something which cuts across some parts of AI, some part of data science, and some part of machine learning, right? So I'll rather say that your data mining, it has actually graduated to machine learning. That's how probably I would like to put that. Right? Okay. Yeah. Any other question? Any other question? Any other question? Thanks, Prithpal. Any other questions? Any other questions? Then let's go now a little bit deep into the machine learning types and processes, right? Machine learning types. So machine learning, if I talk about, on one hand side, we have something called as supervised learning. On the other hand, we have something called as unsupervised learning. Supervised, unsupervised. We have already discussed what exactly is supervised and what is unsupervised. So under supervised, you have regression and business classification. Under unsupervised, you have so many techniques, right? Starting from clustering to association mining, right? So many things are there, right? So see, for example, will a customer click on an advertisement or not? The answer can be yes or no, right? So if we have a large amount of data on advertisements, and for the information whether the customer has clicked on those or not, right? So that becomes a supervised learning part. You are giving me the data. Also at the same point in time, you have given me the result, right? There's a question from someone, Jyotisman, saying that the third type is missing. Yeah, reinforcement learning, as I said, reinforcement learning is not something that we are going to do at this point in time. So again, this thing is going to remain in supervised and unsupervised, right? Reinforcement learning, we are not taking up. Some people, they have raised their hand. Yeah, Madhuri, I think Madhuri has some question. Yes, Madhuri, you can just say your question. Yeah, Madhuri, you have a question? Look. So for the case of unsupervised learning, as I said, that detect the particular patterns, right? Detect the particular patterns, hidden patterns, right? Hidden traits in data. That's what we do in the unsupervised learning part. I think in the machine learning piece, some part of this unsupervised learning part will come in. Types of supervised learning. The first type is regression. So typically, whenever the variable of interest, the variable that you'd like to predict is of some particular number, that leads us to a regression model. So the outcome is continuous or numerical, right? That's the regression problem. Outcome is continuous or numerical. And for classification, the outcome is some kind of category. That's the classification part, right? So for example, as I said, that if you are trying to find out that whether to hold on to a particular stock, right? Whether to buy a particular stock, sell a particular stock. So those are nothing but cases where the outcome is categorical. That's the classification problem. But if you would like to find out that whether the stock price, what the stock price is going to be tomorrow, right? In terms of number, right? Whether it's going to be 100, whether it's going to be 1,000, whether it will come down to 0, right? So here you're specifically trying to predict some numbers. So whenever predicting some number comes in, that is regression, right? So outcome is continuous, numerical, that is regression. Outcome is some kind of a category, that is classification, right? So this is the typical flow of a machine learning problem, right? And I'm saying a supervised learning problem. What happens is that you get some data, past data, and this past data has some kind of a labels on it. So these labels are all those things: yes, no, buy, hold, sell, disease, no disease. So these are basically the labels which are there. So your data is coming with this particular labels. And then what you are doing is you are putting the data to this machine learning algorithm, right? So now the algorithm, it learns from the past data. My question to the class, what does it learn from the past data? What does it learn from this past data? What does it learn from the past data? Ankit is saying pattern. Prithpal is saying rule between the input and output. Vibor is saying trends. Okay. Anything else? Anything else? Anything else? Maybe one or two more answers. Madhuri is saying data points. No, Madhuri, not at all. Not at all. Right? That's the wrong answer. Prithpal is saying relationship. Yeah, fair enough. I think I'll take Prithpal's answer. So what it does, what it tries to find out is that based on the input data, right? Based on the input data, based on the features in the input data. Feature 1, feature 2, feature 3, how the output level can be determined. The output like yes, no, all those things, how that can be determined by the input data, right? By the features of the input data, how you can determine the output. That is what this machine learning algorithm is trying to do, right? So now when the new data comes in, so this new data, it has only got the features. It only has the features, right? It doesn't have this particular label. What is it has is only the features, right? All those feature 1, feature 2, feature 3, that is what it is having. And this model, the machine learning algorithm, the model, what it is doing is helping us do the prediction. And what it will do is it will predict the particular label. So for example, if it's a stock market problem, right? It has already learned the different features and how the features are interrelated. And from that, whether to buy, hold, sell, this kind of things it will probably predict. Disease, no disease, from disease data, right? That is what it will try to do. So if you go to a doctor, the doctor will probably ask for several reports these days. And based on the reports, they will probably do the diagnosis. That's what happens these days, right? And that's how a machine learning algorithm would also like to do based on the past data. So this is the example of supervised learning. So supervised learning, what happens is that you have the data with the corresponding answers. You apply the model on the data. Once the model gets fit on this data, you get this fitted model. So this is the fitted model. And then you come with data without answer. And this model that you have got, you apply this particular model. And then it will predict the corresponding answers for you. So data with answers plus this model, fit that will give you the fitted model. Data without answers from this model, which you have already got, that will give you the predicted answer. Right? That's what happens in the supervised learning. So for the classification, the answer is categorical. So you have the data with labels. So these labels, as I said, yes, no, buy, hold, sell, all that part. And then you are trying to probably make the data create some kind of a model on it. So all this data get fitted, and this is the model that you get. And then this fitted data, this fitted model, what you do is you put it on this unlabeled data. You apply this fitted model, do the prediction, and get the corresponding labels. Right? Anyone, any doubts with this? This is very, very fundamental. Anyone, if you're having any kind of doubts? Anyone, any doubts? No doubt? It is some question, I think. Shashi is having a question. Data for which no answer available or no label are for unsupervised learning, right? Okay, Madhuri is saying, please repeat once again. Okay, let me repeat. So the first thing what happens is there is a training part which happens, training. In the training part, what I do is I have the data. So label data. Label data means data with answer. So feature 1, feature 2, feature 3, answer 1. Feature 1, feature 2, feature 3, answer 2. Right? So like this, I have the features as well as I have the corresponding answer. So these answers are nothing but the labels. Right? So these answers are nothing but the labels. So what I do is I would try to fit in some kind of a model which from the features will try to predict the answers. From the features, it will try to predict the answers. And when I have fitted a decent kind of model, I say that, okay, this is my fitted model. Now I know, for example, for the people who are trying to do this cooking, right? So now I know cooking. And the next time I probably go to MasterChef Australia. There I have been given those features and the model which I have learned. I apply the model and this helped me predict the level. So here the unlabeled data means the data comes with only the features and not the answer. So F1, F2, F3, F1 dash, F2 dash, F3 dash. Here also F1 double dash, double dash, double dash. So like this, this data comes in. So it has the features, but not the labels. And this model, once this model gets applied on those features, what it will give out is the label. So let's say A3 double dash it gives. That's the feature versus this label part. Madhuri, I hope the answer is clear right now. Okay. The other part is regression. In the case of this regression, so Pitpal is saying, please give examples of data features used in real cases. We'll come to that. We'll come to that. Right? Here we are just helping you get familiarized with the terms. I'll come to that. So this is an example of the classification. So here you have this data. So x1 and x2 are the features, corresponding features that you're having, right? And this plus and minus, these are nothing but the labels. The plus and the minus, these are nothing but the labels. And based on this data, what you have seen, what you do is you create a model. So this line is nothing but the model. So earlier you only had the features, right? You have the features and the label. So the different features for x1, x2, they are there. The different values for x1 and x2 are there. And corresponding to that, you have the labels, which is plus or this minus. And then once you looked into the data, you said that this is probably the model which I would like to create, which will separate my pluses from the minuses. It's a categorical problem. Pluses and the minuses, they are separated out. And now let's say a unknown point comes in. Let me give another this thing for the unknown point. So let's say this is the unknown point which comes in. What do you think is going to be the label for this unknown point now? Is it going to be a plus or a minus? So here I have the values of its x1 and x2. I don't have the label. I don't have the label. So what I have done is, based on my x1 and x2, I have mapped that to the coordinate. Right? And see, because it lies on the left-hand side of the line, so as said by our friend Usha, it will be a minus. Whereas if the point lies out here, it lies on the right-hand side of this particular line, it will be a plus, minus, and plus. Prithpal is saying, can points lie directly on the model line? If that happens, then probably you have created a bad model. If that happens, because the objective of the model is to ensure that you are able to separate out the pluses from the minuses. And let's say that if you have created a model like this, let me put a model. So let's say your model was like this. So some of the minuses comes in the plus zone, some of the pluses it goes into the minus zone, isn't it? It's probably a bad model that you have created. A good model ideally should be able to separate out both the classes. Right? Okay. So that was my classification problem. Come to the case for my. So this is some example, more example. Emails labeled as spam or ham. Right? So your email, right? Email. If I have to trust all the emails which I get every day, I probably would have been more richer than Elon Musk. Right? I almost win some few tens and hundreds of millions of dollars every day. Right? If I accumulate that, I probably would become richer compared to Elon Musk. But yeah, here this email is coming. So email is coming with some features. The features are probably the keywords which are there in the email, right? The originator of the email, the text which is there in the email, right? And based on that email, it is being termed as spam or not spam. So not spam is also called as ham. Right? So I feed a lot of email to my system and try to create some kind of a model out from it. So this is my fitted model. And once my fitted model is there, new email comes in with all the body, text, everything. But my model is ready right now. So this new email comes in. This model is put. And it will very specifically, it will say that whether this is spam or this is not a spam. Got the point? Prithpal, does it answer your question? You said that you're having difficulties in this feature versus the label. Got the part? So here the label is the spam and the not spam part. And the features are basically all the other things. The body of the email, the kind of keywords which are there in the email, right? The this thing, the subject line of the email, all those are the features. Okay. For the regression, right? So regression is where the output, right, or the label is some number. So here you have this movie data with revenue. So when I'm saying movie data, it contains so many things, right? Probably the storyline, actors, release time, all those things, right? And most importantly, the revenue part. Right? So many of you are fans of the Khans in this class, right? Salman Khan, Shah Rukh Khan, Amir Khan. You must have seen that Salman Khan movies, right? Bhaijan movies, they will always release it during the time of Eid, right? So what does Eid has to do? What they have seen is that whenever they are releasing the movie in the Eid time, the revenue probably shoots up. The revenue probably shoots up, right? So those are the reasons, right? The storyline is there, actors, right? Arijit Singh songs, right? So many things are there, right? Okay. So you get the fitted model, and now next time, right? Whenever people are saying that, okay, let's create the next blockbuster. First formula is take Bhaijan. You have some practical followers out there, right? Make sure that the movie releases before the Eid, given some good fight scenes, right? And then you have your recipe ready for the next 300 crore movie. Regression, numerical answer, right? So the difference between classification and regression is while in the classification part, the answer is categorical in some categories. In the regression part, the answer is in some specific numbers. That's the difference between classification and regression on a whole. Right? So this is an example of regression. So here you have on the x coordinate the values of x, and on the y coordinate the corresponding value of y. And we'll probably try to fit this to some model whereby for every value of x, we are able to predict the value of y. Right? That's what happens for regression. But again, we are going to do these things in more examples. And again, I have talked about reinforcement learning. So just to give you an example of reinforcement learning. So environment is there, some agent is there, right? And the agent is taking some action on the environment, right? And then it's either rewarded or it is penalized. How many of you have seen that movie, Wall-E? Wall-E movie from Walt Disney. Have you seen that movie, Wall-E? Wall-E movie from Walt Disney. Have you seen that? Wall-E. Okay. So Wall-E movie is basically a classic example of reinforcement learning, right? If you remember that particular Wall-E, which was there. So Wall-E was actually trying to work against a rogue environment, right? A rogue environment in the space, collecting debris and making sure that it is able to save itself also from all kinds of radiations, intruders, right? All these watchers, right? That's what Wall-E was trying to do. Example of reinforcement learning. Chess playing games these days, right? So they lot of cases reinforcement learning is being used. The self-driving cars, right? The self-driving cars, which I think in the next 2 to 3 years it will be actually reality. The self-driving cars. Those are examples of reinforcement learning, right? Some rules have been given, and then the car is actually tested against the environment. So the environment has so many things, right? Kids playing on the street, right? Goats crossing the road, right? All of a sudden, cars coming from the opposite side, and the agent, which is basically the learning mechanism of the car, what it had to do is it had to learn based on some simple objectives. The objective is that you should never go and hit a human or any moving object, right? The order of precedence is highest for the human, followed by probably some animals, followed by probably some other moving objects, right? And through this process of its interaction in the environment, it continuously learns. That's the reinforcement learning, but again, it's not part of the syllabus also. It's a very advanced thing. So we are not going to deal with the reinforcement learning piece, right? Hidden structures with unsupervised learning. So here is what is the unsupervised learning part. You see once again x1 and x2 are some features. And when I map the data point against x1, x2, so by the way, the data point doesn't have any label. In the previous cases, we had some labels for the data points. This time, the data point doesn't have any label. But what I've been doing with this x1 and x2 is that I've mapped the data, and this is how the data looks like. What you can see is that 3 distinct clusters have got created, right? This is cluster 1, cluster 2. 3 distinct clusters of data have got created, and each of these clusters are very different from the other one. Right? That's with unsupervised learning. That's what has got created. Dimension reduction, we probably are not doing this in this particular course, but in the case of dimension reduction, what happens is that from larger dimensions, right, 3, 4, 5 dimensions, we are basically trying to put that into smaller dimension. Right? So here you can see this data. So this data, by the way, is having some label. The label is this red part, this is the yellow part, this is probably the green part, right? This is the blue part, so red, yellow, green. These are the parts, right? So what we are doing is from the 3 coordinates, the dimension have been reduced from 3 coordinates to 2 coordinates. These are some samples. So this is a typical machine learning process. We have already discussed this. You have some training data. From the training data, what we do is that we extract the different features, right? And with the different features, these labels are also there with the features. And this algorithm is there, which will try to estimate. What to try to estimate? That how I can predict or how can I get the label from the different features. That's what this estimator algorithm will try to do. Now, new data will come in. And by the way, this new data will come without label, right? Please understand this new data will come without label. What I'll do is that from this new data, I'll first extract the different features. I'll extract the different features from the new data. I'll pass the features to my estimator algorithm, right? This model, and then they will make the prediction of the labels. This label, if it is a categorical label, we are talking about a classification problem. If this label is that of a continuous value, then we are talking of a regression problem. The recording was stopped. It didn't inform, but yeah. Okay, some part got missed in the process, but anyway. So yeah, that is the process of supervised learning part. So let's come to some terminologies that are being used in machine learning. Now that you are studying machine learning, you should be comfortable with the machine learning terminology. But before that, any questions up to this particular part? Any questions? Anything that you would like me to repeat? Any questions that you'd like me to repeat? Any particular piece that you'd like me to repeat? So I'll take on the terminologies in machine learning, but yeah. Anything that you'd like me to repeat? No? So let's move ahead with the terminologies in machine learning. So these are the terminologies which you'll find commonly being used in books, right, in blogs where they're writing about machine learning and everything. And those are the ones that we are also going to use. The first one comes is something called as a target. So target is nothing but the predicted category or the value of the data. The predicted category, right? The value that you're trying to predict. That's the target, the column to predict. So here is the data that you're having, right? And from the data features, what you're trying to do is basically you are trying to put the flower species. The flower species. So species, as you can see, Virginica, Setosa, right? Versicolor, right? So these are the different species of the flower. So this particular column itself is my target. Because after my learning is done, that is what I'm going to probably target, or that is what I'm going to predict. In terms of the features, these are the features: F1, F2, F3, F4. These are the features, right? So sepal length, sepal width, petal length, petal width. That's how probably a botanist would try to give some kind of a value for the target. Fair enough? Okay. So the first thing which you learned is the target part. Right? So this is my target column. The next thing is obviously the features. So features are the properties of the data used for prediction, or the non-target column. The properties of the data used for prediction or the non-target column, they are the features. Right? So here, all these four: sepal length, sepal width, petal length, petal width, they are my features. They are my features. Right? Sepal length, sepal width, petal length, petal width, they are my features. Right? Fair enough? Okay. Third is an example. So what is an example? So example is nothing but a single row of data. A single row of data is an example. An example will contain both the feature as well as the target value, right? So here's an example. So the features are: this sepal length is 4.4, sepal width is 2.9, petal length is 1.4, and petal width is 0.2. For my target, the value is Setosa, right? And the last one, which is called the label. So label is nothing but the target value for a single data point. So the previous example, this Setosa is the label for this particular example. So while this entire column is my target column, right? This species is my target column, right? This one row or one line is the example, and the value of the target for that example, that is my label. So here, this is my label, right? Everyone understood? Everyone understood, right? So we talked about the target. We talked about the features. We talked about example, and we talked about label. Going ahead, I recommend, I suggest that please use these terminologies. Right? Okay. All good till now? Doubts, questions, anything? Anything where you would like me to probably redo this part again? Questions? Any questions? Nothing? Let's move ahead then. Let me come to a very, very important part, which is data pre-processing. Data pre-processing. Very, very important, very, very fundamental and important, right? So data pre-processing, why it is required is that your raw data is often pretty incomplete, sometimes even noisy, right? It contains values which are obsolete, values which are missing, values which are way outside the bound, called as outliers, not very much suitable. They might contain some kind of errors, right? So these are the reasons why we do some kind of a data pre-processing. So let me help you out with some examples, right? And yeah, so these 5 records are some examples of data. These 5 records, as you can see on the screen, are some examples, and what I would like to do from this data, is that from this example, I would like to find out if there's some problems in the data itself, right? Okay, I'll probably ask one volunteer after the other, and what I'll ask you to do is, can you just say that for customer ID 1001, this particular example. So by the way, all these are my attribute, and this is my target attribute. This is my target. Okay. So for the first example, example 1001, can you tell me, does the data all look good, or there are some problems? Yeah, I can have some answer on the chat. Most of them you're saying, most of you, you're saying that age C is a problem. And yeah, age is supposed to be numeric, right? How come it is C? Sure, right? Point well taken. Okay, come to the next example. Example number 1002. What do you think the problem is there in this particular data? 1002. Okay, people are saying income and the zip, right? So income we are seeing is in negative, while the zip, right, it is probably a little different from the other one, right? Income is negative and the zip what we see is different from the other one. Okay, fair enough. Someone said also the marital status. Marital W is fine. W is pretty okay. W stands for widowed. W stands for widowed. Okay. Okay. Come to record number 1003. What do you think is the problem out here? 1003. Gender missing. Right? The gender is missing. Is that the only point? Gender is missing is correct, right? But is that the only one? Is that the only one? Income. Very good. So gender, first of all, the gender is missing. And the income part, you see, right? If you compare the other one, the income is way high compared to anyone else. While the insurance amount, if you see, is probably the lowest. So someone with a very high income, ideally, should be having a very high insurance also. Insurance, by the way, here is my target variable. But again, I don't think that it is converting to that. Okay, good. So come to the next one, 1004. So what are the problems in 1004? 1004. Okay. So there are two things. One is this particular zip code which is out there, 4 characters, right? And then the age part, right? Age 0. See, age 0 and insurance is there. It's pretty okay, right? Because still the person doesn't complete a full 12 months or 1 year, right? Still you can get some insurance, right? That part is pretty okay. But see this income part. So until unless someone is the grandchild of Mr. Ambani, I don't think at the age of 0, income of 50,000 is possible. So definitely problematic, right? What are the last one? What about the last one? What are the last record? Madhu is saying no problem. It is saying no problem, no issues. Yes. The last one is pretty okay. It's pretty okay in all respect. Okay. Now let me come back to the example once again and Let me take the first case. The first case, age was C. Age is supposed to be a number, it was C, and definitely it's a problem. I'll tell you the origin of the problem, right? So in Japan, people are there who frequently are 100 years or over, living healthy, right? They do all their work, all their regular course, right? See, whenever you take this data comes from multiple systems. So here was the system where the age was encoded in 2 characters, right? So the assumption was that, okay, I mean, people will generally live up to 99 years, right? What's the use of 3 characters? I'll put as 2 characters. Now, when in that particular field, you're trying to map the age of someone who is like, let's say 100, 105, 108, 112, obviously those three characters, it was not coming in. If I take the first 2, it will probably be 10. That's also wrong. If I take the last 2, that's also bad, right? 01, 03, 05, 12, right? That's also bad. So someone very smart, what he did was, he said, okay, fine. Let me, since I require these 2 characters, let me put centurion for them. And how do I know they're centurion? I'll just put C. That's it. Now, when this information probably flew down, the assumption got lost. And here you have data with the age of C, right? Which probably is not that much suitable for doing the machine learning, right? So that was the problem with the first one. The second one, zip code, as you guys have said that it is alphanumeric, it is wrong. I can tell you, right? See, if you see the other part of the data, to us also it seems it is wrong, right? To us also this seems it is wrong, the other part of the data if you see. But here, what we see is that in some places in British Columbia in Canada, right, and in some places in the Middle East, we actually have a tradition of having alphanumeric zip code. So this particular part is pretty okay. Come to the other one, which is income. Income minus 40,000. Yes, that certainly we find it challenging. But I'll tell you what has happened out here. Income minus 40,000, right? So typically there are 2 or 3 reasons for it. One is probably there was some kind of a dollar sign out here. And since this particular field, when it came by, you can't take this dollar sign. So that's why this dollar sign was replaced with this minus sign, right? So typically by data encoding problem, this problem would have come in. Other case is probably this is someone who had taken a lot of loan from the employer, and rather than probably giving the employer giving this particular money to the person, he is probably giving this particular the employer this particular money back. Say for example, if I see the notice period time, so notice period time, and let's say that you are not basically fulfilling the notice period. So what happens is it's the other way around, that rather than the employer giving the money, the employee has to give the money to the employer, right? That's where this minus thing had come up. In any case, it is probably wrong, and we'll try to create some kind of a imbalance in my system. Come to the case of 1003. For the case of 1003, I see the gender is missing. So missing data is always problematic. Now, generally for data which is missing like this, the common way in which you are going to replace this missing value is probably use the average value or the modal value. So average value means if it was a numeric field, rather than gender, if it was something like the age, I probably would have just used the average of the age to replace this value, right? Here, it's the number is not numeric, it is categorical. So this particular case, I'll probably take the gender which occurs the maximum number of time, the modal value, right? In either case, it is pretty wrong. It's pretty wrong, right? Because here you are misleading the data. You actually don't know what was there out there, and you have actually misled the data, right? So, but again, you don't have any options. So either use the modal value, the value with the which is occurring the largest number of time, with the hope that okay, this value will probably get replicated out here also. That's one way of doing it. The other thing that you can do is probably you can give it some kind of a different level. If you see that there are so many data points which are having this U, which stands for unknown. In fact, I can tell you a real life incident. Even some 3 or 4 years back in India, if there was some form that you have to fill up for any purpose, the gender was only male and female, right? There was nothing else, right? Or sometimes prefer not to say things. So if you put a prefer not to say, obviously it will come as this blank. But particular person has preferred not to speak about it, right? But see, these days you'll find that there is some kind of a third gender, right? That also is getting featured in this application forms, right? So in the earlier system, probably this provision was not there, and this kind of people, they probably didn't find any option for them and kept it as black. I'm just saying some hypothesis. So this is how you get these problems in the data, right? Okay. So sometimes if you find that there are many records where these values are missing, probably replace that with something like this unknown U, right? Come to the other part, which is this income. So income out here is pretty high. Obviously, we need to investigate that whether this high value, was it really high, or whether there was some kind of a problem with it. I'll give you an example. So let's say we talked about your organization, right? In the organization which you work, right? So there is some kind of average compensation for the people in the organization. Sure, it is there. And then you have some people, like probably these blue collar workers. So if they're also part of the payroll, like the janitors, people who cleans the toilet, or the people who probably serves you the food, their salary, you find it is very, very small compared to your salary. You might think that, okay, it's an outlier, it's a problem. But again, that's a real data point. Vis-a-vis, let's look into the CXO level. Let's look into the CEO salary. His salary is way above compared to anyone else's salary in the organization, or the CXO level people, right? The CFO and all those pieces, right? So for those pieces, this value is not a wrong value, it's a correct value, right? Or it might also happen that during, so this was probably in some other currency, and the process of conversion, maybe you've got those extra zeros, or the data actually had probably a dot out here, and it could not recognize the dot. It just took this zeros as it is. So many problems can happen. Cases like this requires more investigation. The case which I talked about, where probably this refers to some kind of a salary for the CEO kind of people. Maybe what you can do is you can just do some feature engineering, add another field called, let's say, my employee. So level, it is level. So this is, let's say, regular. This one, let's say if it was a worker, so blue collared worker. This one, let's say a CO, this thing. So CX level, right? Reg, like this. You can actually create a new flag in the whole data, so that whenever someone tries to create a model from this, the model knows that, okay, the data was small because it was a blue collared worker. The data is very high because, again, in the flag is given, it's a CXO level. For all the other cases, it's a regular case, right? So these are probably some of the things that you can do, right? A lot of data cleaning are required, right? I hope you got the point, right? I hope you got the point. The explanation is there. The slides have been shared with you, right? You will get the idea. Okay. The one thing which I have missed out is this particular part, the S part. So here, this S is a little bit challenging in the sense this S can stand for single. So probably for the age 0, the S is single, and the other S can also be separated, right? We don't know that. That's also something I think which just went out of my bracket. So see, just 5 lines of data is what I showed you, and so many kind of variations, so many kind of examples, so many kind of instances could have occurred just for this 5 lines of data, right? Okay. So handling missing values, right? I'll come to this particular part in the next class, the missing value part. So let me show you this one, identifying the misclassifications. After I do this, I will go to the missing value part. So here's the data, and here are some of the counts. This is all fine, or we need to probably relook at it and make some changes. Is all fine, or should we need to relook at it and make some changes? What do you think? What do you think? The data, is it all fine, or we need to make some kind of a changes out here? Just look into the data. Shashi is saying US and US will be the same. Very good. Jyotish Pandit was saying the same. Okay, anything else? Anything else? Yes, Russell, France comes under Europe, right? See, these are things that you know from your domain knowledge. That's why you could say this, right? So this US, what I need to do, US, what I need to do is I probably need to remove this. It will become US, and then this will have +1 equal to 157. So this whole line will go away. France, as you know from your knowledge, it comes under Europe. So I can remove France and make this, right? So this kind of a problems can be there in the data. So this also comes under the data cleaning part, right? So this also comes under the data cleaning part. Right? Okay. So that is the misclassification part. Okay. If we come to the previous ones. So which is this handling missing value, right? So missing value, as I can understand that it's always a problem, right? And if your database is containing a large number of fields, right? Missing value, it always poses a problem to the data analysis. Right? Having lesser information is clearly not very good, right? So yeah, you need to take into more information. But what to do with the missing values, right? See, one thing which you can do with the missing values is, so I'll tell you a rule of thumb. If less than 5% of the data contains these missing values, just go ahead and delete those records. You'll save yourself a lot of time and hassle. If less than 5% of your data contains all these missing values, just go ahead and delete those values. Right? In that way, as I'm saying that, you'll save yourself a lot of time. But again, if more than 5% is there, yes, that's a challenge, that's a problem which is out there. Right? In this particular cases, then carefully what you need to do is probably you need to look into these values. So for example, here, see the continuous data, categorical data, continuous, categorical, continuous, right? For the values which are missing, you can replace these values with the average value or the mean value. Replace this value with the average value, which, by the way, as I said, will create some kind of imbalance, right? In the sense that you are actually fudging the data. But again, you don't have any options remaining with you. Okay. For the other one, the categorical pieces, you see cylinder. So you know cars come with 3-cylinder, 4-cylinder, right? 6-cylinder, 8-cylinder. These values are missing. What to do? One way of doing it is that you just go ahead and remove the data points. But again, if you remove the data points, you don't know that whether you've done the, I mean, if you remove the data points, basically the number of data points gets reduced. So one way of handling this is that you probably take the cylinder, which occurs the maximum number of times. Out here in the data, I see the cylinder 8. It occurs in 3 places, just in the small sample. I'll probably use the data. And these missing values, I'll probably make them as 8, 8, 8, 8, like that. But against these values, here, say for example, this one, so you're taking the average of all the other points. It will come something around 200. Right? So whether it is correct or not, that itself is a major challenge. This will come as 200, this will come as 200. But see this one, the one which is having data, this is 350. And here, since I change it with the average, so this missing value for 8 comes out as 200. I have tampered the data real time. But again, the thing is that I don't have any other methodology to which I can handle this. That's the problem. So either I go and delete those records, that's one way, or probably I handle the missing values. Right? So Shashi is saying in case of outliers in the data, the mean value is misleading. Yes. For the cases of outliers, so generally I suggest that rather than using the mean, use the median. Use the median for outliers, or even for data which is skewed, right? Which is higher on the one side compared to the other. So use probably the median as compared to the mean will be better, right? So these are some of this thing. Okay, so here they are saying that the mode was 4 out here. So for 4, they have replaced that with the data. But see, in the real data, 4 had a cubic inches value of 89. 4 had a cubic inches value of 89. And here 4 is having a cubic inches value of 200. So we have probably created a new beast altogether without even knowing. Right? So these are some of the challenges which are there. Right? So again, substituting mode or mean for missing values sometimes works well. Mean is not always the best choice for typical values, so use the median, right? So these are some of the things that you should be doing, right? To handle the missing values, right? So you can also use some kind of a graphical method for the finding out the outliers. So graphical method, you can see if I plot the data. So here are some of the ones which probably features as some outliers, right? You are having cars with very, very small weightage. How it comes, we don't know. Yeah, we do doubt the validity of this car. If someone create a car completely using cardboard, we don't know. Or maybe plastic, that's why it is showing so low. So those are some of the ways in which you can handle these outliers. So you got the graphical methods, right? So here you can see that here is a car with a very small weight, right? Very small weight. And on the other side, we have some car coming from the future, right? Which is giving a very high miles per gallon. Let's see all the others miles per gallon and this one. I think probably it uses the air or something, maybe the carbon if you can use as the this thing. So then probably this kind of a things are what you can see if you plot the data, right? Outliers. Measuring the central tendency, I'll not probably proceed further. I think we have covered enough for a day. I'll stop, and as I said that I'll make the session open so that you can ask me questions. Yeah, I'll just see that how I can this thing allow to talk. Let me just see. No, I don't see any way in which I can probably unmute everyone. But again, if you're having some question, yeah, please raise your hand. I'll probably come to you one by one and try to unmute you. I'll probably come to you one by one and then I'll try to unmute you. Any questions? I hope it was understandable, right? I know people have come from diverse background in this section. Some people are very good in the technical part. Some people doesn't have any technical knowledge. But I hope at least this first session, it was understandable to everyone, right? It's very important to have a good foundation on which we can build further, right? Any questions that you're having? Any questions? Yeah, you can just raise your hand. Anyone? No question? Yeah, I know I'm coming between you and your lunch on a Sunday. I know that. But yeah, just in case. Okay, so I think it all seems good, right? So in that case, so okay, Pritpal is asking how will be the IS. So IS typically is based on your async content and whatever we have done in the class. So if you have watched the async content, the notes in the async content, gone through my class and the notes, IS are basically this we have MCQs. So I think MCQ and one subjective question. So it will all come from this thing. So it will have one DQ as well as quite a few MCQ. Pitfall is asking, will we be doing any programming in this subject? Yes, we will be doing. We will be doing programming, right? Whereby the models that you are learning, some of the models we can implement. Yeah, we'll be doing that. We'll actually be doing that, right? Okay. So Madhu is asking this software. The software that we are going to use is Python. Python is the language that we are going to use. Software is Python, and that's what we are going to use, right? In fact, in your async content, you'll find that there are optional contents where we have this data set with the Python pieces, right? It's already out there, right? Okay. So I think T will have live coding. We'll see. T is quite in the distant future. We'll see what we can do for the T is part. Right. As of now, let's enjoy this course, right? And yeah, I'll take up the this thing, the hands-on part as and when it comes, right? But again, at least for the first 2 or 3 sessions, we are typically going to build your concepts, your learning, your fundamentals in this machine learning part. I hope this session was useful to everyone, right? Please put your feedback in the feedback form which was shared by the subgrad, right? So that it also helps us know that what well we can do for you, right? If you like the session or not, right? It also helps us knowing you in a good way. Fine. So I'll not spoil your Sunday any further. I think we are going to meet again next week. So till then, take care, everyone. Go through these notes, go through this in content, go through this class content also. Come back with some questions which we can discuss at the beginning of the class, right? Fine. So I'll see you next week. Till then, bye-bye.